Hello. Today's topic is multifamily central domestic hot water recirculation controls. Build a Green is presenting this webinar on behalf of the Energy Network, which is a local government organization created by the California Public Utility Commission that provides resources and assistance to homeowners, businesses, and public agencies planning energy efficiency upgrades serving the Southern California region. These services include community education and outreach, such as these webinars, rebates and incentive offerings, attractive financing terms, and tools to help identify contractors that have been trained in energy efficiency. Additional resources help homeowners take the next steps towards saving energy. The Energy Network has a great program for multifamily property owners, and we'll tell you a little bit more about that towards the end of our webinar. As a property owner, you're in the business of creating homes for your tenants. And as a building professional, you're in the business of creating healthy homes for your tenants. You can offer a comfortable and healthy environment that they'll cherish while at the same time saving yourself maintenance costs and setting an example for the larger community. Innovative water conservation and energy efficiency solutions like passive house, passive heating as well, solar water heating, electric charging stations, drain water heat recovery systems, and living roofs have all begun to take hold in our cities and are making their way to all parts of the state. Residents are not only soon to become better educated about resource conservation, but they'll begin to look for properties that reflect those values back to them. Today's presenter is John Neal of the Association for Energy Affordability. John specializes in working with multiple parties to manage and deliver successful building performance retrofits. He conducts energy audits, provides green building consulting and rating services, uses simulation software and outside engineering calculations to model building performance, as well as diagnoses and resolves building performance issues. He develops retrofit specifications, commissions equipment and systems, and performs quality control and assurance for multifamily and commercial retrofit projects. Additionally, he contributes to multiple local and national committees which develop multifamily standards, certifications, and technical guidelines. He's a project manager at AEA and a self-proclaimed energy geek. With that, I would like you all to join me in welcoming John to our webinar today.
Thanks, Leela. Get my screen set up here. All right, Leila, can we see my screen?
Yes, you are good to go.
All right. All right, so today I want to talk about domestic hot water recirculation controls for multifamily buildings. And this is sort of an intro here just to give you a flavor of how I sort of started to approach this presentation. There have been a variety of recirculation control studies performed recently with a sort of range of reported gas savings ranging from 10% to 45% gas savings. So we have quite a bit of studies that are sort of moving us in this direction of looking at domestic hot water recirculation controls. And I just wanted to spend today sort of talking about when they can work and when you need to be cautious and make sure you assess buildings properly to ensure that they will be implemented properly. But I want to take a second just to take a step back and talk about what are domestic hot water recirculation systems, just for any folks that might be in the audience today that want a little intro. So domestic hot water recirculation systems are pretty typical for most multifamily buildings that have central domestic hot water plants. And a domestic hot water recirculation system is essentially, as you can see in the sort of upper left diagram here, a pump that is used to circulate hot water from the central hot water plant throughout the building to provide continuous hot water availability to sinks, showers, bathrooms, etc. You can see in the bottom right-hand corner here, the pump in the picture. That's sort of an example, a typical central hot water plant pump that you might see. So the agenda for today that I have is to sort of go through different types of recirculation control strategies, explain what issues might arise when implementing those controls or those strategies, and then provide suggestions for evaluating existing buildings. You know, will your control strategy work, or will you potentially run into problems? And then if we have time, I'd like to discuss options for new construction projects as well. And I'm going to sort of break this down. The beginning, I think, will probably be more useful for building owners and auditors and raters alike. And then the end, I'm going to probably get a little bit heavy into the diagnostic side. So sort of spare me if that is beyond what you're interested in learning about. But if you're interested in sort of getting into the diagnostics, that'll be sort of in the second half. Okay, so we have three different types in general, sort of groups of different types of recirculation control strategies. The typical recirculation control strategy is actually no strategy whatsoever, one where the pump runs continuously in the building. I would say this is what I see on most multifamily buildings, regardless of the building size. Then there are strategies that adjust the pump to maintain a water loop, so the hot water loop, at a usable temperature. So the pump is doing some sort of control to maintain whatever temperature you want in that loop. And then there are strategies that lower that loop temperature below what you might consider a usable temperature, so below 105 degrees, anytime when the usage is not predicted. So anytime that the pump or the building might not need domestic hot water. So I'm going to go through some strategies that maintain that set point. So a typical strategy that you might see in a building is an on-off, a simple on-off temperature control. And what you're seeing here are sort of two different types of temperature controls. The picture in the left is a Honeywell Aquastat. That, if you see that connected to your pump, might be connected to that little copper temperature sensor, might be strapped onto your return line or in a dry well sensor location on the return line. And that type of control allows you to sort of adjust when you want your pump to turn on and when you want your pump to turn off to maintain sort of a usable temperature in the loop. On the right-hand side, you can see a clip-on Aquastat controlling that recirculation pump. And those clip-on Aquastats are helpful because they're very low cost, very easy to install. They come in typically sort of two different temperature settings that you choose when you purchase them. The disadvantage is they don't really give you any control, so you can't adjust them to turn on sooner or later if you are experiencing any sort of recirculation control or recirculation issues in the building. And then we have strategies that maintain the set point in the building. So the pump is doing something, or there's a strategy that's trying to just maintain exactly the temperature that you need. And there are a couple of different strategies. One strategy is letting the pump run continuously. As you see in this upper picture, there's no thermostat installed or Aquastat installed, but there has been a circuit setter, which is a balancing valve that's been installed behind the pump. You can see the red arrow pointing to that circuit setter there. And what's happening in this scenario is the circuit setter has been adjusted to reduce the total flow rate throughout the domestic hot water recirculation loop to just exactly the amount of flow that's needed to maintain hot water availability in the building. You'll see this a lot in buildings with aggressive water or hard water problems to reduce the sort of corrosive effects of pumps that can damage piping over time. The other advantage is you can also reduce the flow rate to just maintain the temperature that you need in the pipe. And And then another option, this is sort of an emerging option, is to use a variable speed pump. And the picture shown in the bottom right-hand corner is a electrically commutated motor type pump. So this is a new, very energy efficient pump that includes controls that will allow you to run the pump to just maintain the temperature that you want in the system, and it will speed up and speed down using its own controls to maintain the temperature that you want in the system. I'll get into those a little bit more and talk about the pros and cons for those new pumps. And then we have strategies that lower the set point in the loop. And the idea here is that if you don't have somebody, if nobody's using hot water, then you don't necessarily need to maintain usable hot water temperature in the loops. You only need that hot water to be at a usable temperature when somebody is about to use the water. And so the strategies that are available for lowering the loop set point can be achieved through the installation of a demand controller on your recirculation pump. And these work by, there's a couple of different products available, but the general idea is that they will either use a flow switch or a temperature sensor to determine what the usage patterns are in the building, or to determine when hot water is being used in the building. They'll use that information to turn the pump on and only run the pump either when the demand is sensed or anticipated in the building, or when it senses that the return line has gotten too cool to be usable, and it might prime the loop just to maintain a somewhat usable temperature, sort of try and keep the loop at a sort of a warm temperature, not a cold, but not necessarily hot. Then they have, I think a lot of you will probably be familiar with the single family demand type controlled pumps, which are a small pump that is controlled by the occupant of the building with either a push of a button, the activation of a motion sensor, or some other sort of trigger that will turn that pump on and circulate the water throughout the loop. And those are typically more prevalent in either single family homes or I would say very small multifamily buildings, lower than 5 units or 6 units, where maybe each tenant has a button, but typically not seen in multifamily central hot water systems. There's a couple of other controls that lower the set point of the loop in the building. Another control option are what they consider to be boiler set point controls. And these don't actually control the recirculation pump, but they control the set point temperature of your domestic system. And sort of like a demand control, they will watch the demand profile of the building, and when it's sensed that there's not a large demand, that will reduce the set point temperature of the domestic system. This is really, I see this really as more of a load matching control than a demand control. So when demand is sensed, the temperature will be increased in the system to what's anticipated that's needed, and when the demand isn't sensed, it will lower the temperature down to what still would remain as a usable temperature. And this is usually happening at night, or if you have a building that has a lot of sort of working families, maybe during the daytime as well. And then another sort of strategy that you might see are timers. And many recirculation pumps that you buy for domestic hot water recirculation will come with a timer built into the pump. I believe Title 24 code requires, either some sort of recirculation control, and one of those is a timer and aquastat type control. Unfortunately, in multifamily buildings, especially in larger multifamily buildings, timer isn't, we typically don't recommend it, because the odds that somebody might need to be using hot water in the middle of the night or in the middle of the day is highly likely. not everybody maintains a 9 to 5 schedule. So given a variety of sort of load profiles and use profiles from our residents, we don't typically recommend using a timer. That being said, if you have a commercial facility where something is shut down from a certain time to a certain time, we definitely recommend a timer in that situation where you can control and know when your space is being used. So at this point, I'd like to sort of gone through the different control strategies, and I'd like to talk about the issues that might come up when implementing controls. And before I move forward, does anybody have any questions on any of the previous slides?
It looks like so far no one has any questions. I'd just like to reiterate that if you do have questions throughout the presentation, you can use the questions pane or the chat pane and submit that to us. But so far, John, looks like no questions.
Cool. All right, so I don't know how many folks have heard about crossover problems in multifamily buildings. So I want to try and spend a little bit of time talking about crossover and how that can create issues in your building. So this is a sort of a very simplistic line diagram of domestic hot water system, and I'm going to try and get my highlighter set up here. So in this diagram, we're showing sort of a 2-story building with a domestic hot water heater, recirculation pump right here, and hot water in this diagram moves out of the hot water heater and into a shower mixing valve on floor 1. Hot water moves up, moves into a shower mixing valve on floor 2. And this side over here is the cold line that's entering that mixing valve. So what happens when a shower cartridge seal fails? And this is a seal that's within that mixing valve, within the cartridge, that helps control the amount of hot water and the amount of cold water that comes out of the shower. Now I have to get this to click. Let me go back here. Oh no. Highlights. There we go. So you can, what will happen with old mixing valves or old mixing cartridges that begin to fail, what can happen is this issue called crossover, wherein somebody on, let's say, the second floor up here is using hot water, and the mixing cartridge seal on this first floor, if that has begun to fail, it may allow cold water to come through passively through this valve, enter the hot line, and come up here to the second story valve. And so this person on the second floor will complain of either cool water temperatures coming out where it never quite gets hot, or it takes a long time to get hot. This could be a symptom that the unit below them or upstream of them, that their cartridge mixing valve has started to fail. And this is typically just in single handle cartridge mixing valves, although there are some other instances where you might see crossover happening, typically in older washing machines. There might be a cross connection in a washing machine. And another sort of anecdotal typical instance is if you have a janitor closet somewhere where they've installed their own shutoff valve on the sink and leave the handles turned on all the time. Those are sort of opportunities for crossover in a building. So I think the point here with crossover too is that it's typically masked. The issue is masked when you have a constantly recirculating system. So in a constantly recirculating system, you might move enough water through this loop to dilute this cold water that's entering the line. And if that's the case, residents might not complain or might not know that there's a crossover issue until you start turning this pump on and off, which will allow the line to cool and allow this cold water to sort of enter. Some other symptoms of sort of understanding when you might have crossover connection with a constantly recirculating pump is if you go into your boiler room and you notice that the return line temperature, if you have a gauge or if you can measure the temperature of the water, is significantly lower than the temperature of the water going out to the building. So a large delta in temperature between the return and the supply can indicate that you have crossover. I would say that anything in most buildings, if you don't have a large demand on hot water, a 5-degree temperature drop would be normal. 20-degree temperature drop would be abnormal. And then Ream here have a link, which I think we'll follow up. That link should work when you get your slides afterwards. That's a pretty good diagnostic manual for how to find crossover issues in a single-family building. But the sort of idea and practice for diagnostics are sort of well described for the single-family building. There are some other strategies for identifying crossover. I know that one manufacturer of a demand control is sort of piloting a sort of shutoff test where they'll turn the water off to a building and watch to see how long it takes for the hot side of the system to regain pressure. So there's a variety of different strategies, but a lot of times this can be happening behind the scenes, and it's not typically visible to you until you start changing that pump strategy. Okay, so I'd like to talk about issues that might come up related to balancing. So this is a similar sort of line diagram. I've simplified it to just show three units on a bottom floor and 3 units on a top floor in the same sort of 2-story building example. And if you have a constantly circulating pump in this example, what you might actually achieve in practice is an imbalanced supply of hot water to each of these risers. And to sort of explain this, you have the pump here that's circulating continuously. And it is going to look for the shortest or the path of least resistance here when the pump is running, which is this path right here, closest to the pump. Most of the flow is going to go through this first riser unless there's some mechanism either here or here to encourage water to go to this second riser. So most of the water will go to this first riser, then some is going to continue to be circulated down this second riser, etc., down to the third riser. So in practice, in a constantly recirculated building, this issue might not be noticed. You might move enough water through these further risers so these folks don't know that there's a reduced water temperature, that there's an issue, because you're constantly moving hot water through the system. But in a bigger building, or in a building where maybe this is more aggravated, what can happen is this can actually result in a bigger sort of spread of temperature imbalances. So that furthest riser might only be getting enough flow rate to maintain a what would be considered less than usable temperature in the hot water line. And this can typically be aggravated when you start controlling that pump. If you start turning it on and off, the first riser might look like it's fine. So the stack of folks over here will say, we're getting plenty of hot water. It's 125 degrees. In the boiler room, you look back here at the pump, you're getting 115 degrees back at the pump. This would indicate on first glance that everybody's okay. But if you go out here to this furthest riser and this pump is turning on and off, this third line might be cooling. It's cooling at a similar rate as the first line, but it's not getting as much hot water through that loop, and therefore the line is quite a bit cooler. So Joe up in this upstairs apartment here might be the guy that's complaining. And if you implement a control like this and you get a complaint, this is something that you might want to look at. Are your risers balanced? Is there any sort of balancing mechanism there that will allow you to sort of adjust these systems? The other sort of caveat here for those of you who are familiar with the demand control, the demand control will look at the return temperature that's coming back to the pump and the flow rate that's going out from the domestic hot water system. And if it sees a usable hot water temperature back at this return line here, which is what we're seeing now, 115 degrees, it might not recognize that Joe out here in this further part of the building actually has a colder riser, a colder loop, and doesn't have usable water. So Joe might be asking for water or for hot water by turning the valve on, and the pump might not recognize that the loop is cooler out there, leaving Joe unhappy in the middle of the night. So here's some other issues to consider when thinking about domestic hot water distribution in your building. I think most of us are considering or have installed lower flow shower heads and aerators, especially in light of the current drought. The thing to consider, however, is that by lowering the flow rates of those devices, that will further slow whatever delivery time you currently have to the fixture. So it's something to keep in mind. I think we would always push to use more aggressive and lower flow rate shower heads and aerators. But if you currently have a delivery problem, sort of a long delay time in an apartment, this will make it worse. So this is sort of a flag to determine why the delivery time currently isn't working and come up with some strategies to fix that in conjunction maybe with installing shower heads and aerators. Contractors are pretty knowledgeable with standard recirculation control systems, but they're just starting to, I would say, to generalize, they're just starting to become familiar with central system demand controls. So if you're trying to implement a new strategy, you will want to look for a contractor that has previous knowledge with the system, or work with a manufacturer's representative to ensure that the contractor, that they can work with you and the contractor to make sure control is installed properly. Owner checkbook. So installing demand controls or any of these other control strategies can be relatively inexpensive, but resolving larger distribution problems in the buildings or performing additional diagnostics if the controls don't work, those costs can start to add up. So I always recommend that we not only budget for the recirculation control, but we also try and figure out if there are any issues to begin with, but let the owner know there might be additional costs associated with ongoing diagnostics or repairs that pop up that maybe weren't expected once a control is implemented. There are also domestic hot water mixing valve. If you have a mixing valve in your building, so a central anti-scald mixing valve, those may have compatibility issues with recirculation pumps that turn on and off. That's something that you'll need to discuss with your contractor or a manufacturer's representative of a demand control to ensure that that's not an issue if you do have a central thermostatic mixing valve. And then another concern is that demand controls and some of these other controls are pretty easy to bypass. They're easy to turn off or unplug and just let the pump go back to a continuous mode. And that's really helpful if you need to resolve a problem that's popped up quickly and bypass a pump. But the other concern is that if your maintenance staff is not communicating with you as the owner or you as the rater, and they've bypassed the pump due to an issue, you're not going to achieve any savings. The other potential concern is that if you purchase a demand-controlled pump package that includes a new pump, sometimes those pumps are sized larger than a typical pump to help move water more quickly through the system when the pump is engaged to turn on and turn off. And if that larger pump is bypassed, you'll start using more energy use than you did before because you now have a larger pump that is running continuously.
Hey, John, we have a question for you.
Great.
So when you mentioned crossover, can you get crossover where the cold water never really gets cold?
Yeah, I have heard of instances where you can have warm water diluting into the cold water line.
What do you do about that?
Well, I think the same. We'll talk about solutions for crossover in a little bit. But actually, going back, let's see if I can get back to that slide. So one other thing I didn't mention on crossover that sort of helps understand why this might happen is that the cold line is coming in at your city pressure to the building, which might be, let's say, for example, this might be 50 psi. The recirculation pump, when it's operating, induces a lower pressure in the return line that's before the pump, which will lower the pressure on this line. So typically, crossover happens when you have a higher pressure water moving to a lower pressure water. So in this case, cold moving over to hot. And that's, I would say, more typical, but I have heard of the opposite being true, where hot can move into the cold line.
Okay. Is that possible that it's an example of cartridge seals failing?
It could be, although I would look for maybe other any other sort of crossover opportunities that might be happening at the building. The washing machine example or the janitor closet example. But I'll talk a little bit about cartridge mixing valves and some suggestions for how that might get fixed as a trial.
Great.
Got lost here. Okay, so I guess my other two sort of soapbox notes here on controls are that the studies I mentioned at the beginning of the presentation focused on gas savings. I'd really like to see future studies also include water consumption monitoring to make sure that we're not just looking at one half of the picture. We want to make sure that we're not causing any sort of additional water use where, let's say, a control gets installed, it's doing what's expected, it's cycling the pump, but maybe residents now have to wait longer. Maybe Joe in that upper apartment has to let the water run for 5 minutes to get hot water. We want to make sure, especially in California, that even if we're saving some gas, that we're not wasting water in the process. And then, lastly, if you have a problem in the building and you implement, if you have a domestic hot water recirculation problem in the building and you implement a control strategy, those problems will only get worse. They're never going to solve your problem. So that sort of leads me into, how do we know if we're going to have a problem? And then what do we do to fix it? I'm going to try and speed up a little bit here too. So what type of building do you have? Is it a simple, 10-unit building that's a single story? Or is it a multi-story building or a complex of buildings that's all served from one hot water heater? Generally speaking, if you have a single story building or maybe even a two-story building with a single loop that runs through the building, without sort of risers, as in the earlier examples that are being recirculated, demand control, temperature control, those strategies should work pretty easily and probably will not require the sort of diagnostics that I'm going to describe. But if you have a larger building, a building where you have known issues or a complicated sort of distribution layout, then you're going to want to go through some of these diagnostics to make sure that the control will work when you implement it. So I recommend first starting by, if you as an owner are not familiar with this, field verify wait times in the field. So measure how long it takes to get hot water temperature in a sample of locations. And at the same time, see what the aerator flow rates are in those places. That way you'll know what the sort of existing condition is. Investigate the piping distribution of the building. Do you have access to the piping? Are there balancing valves? Where do the lines run? And are the pipes well insulated? If your pipes aren't insulated in your building and those pipes are maybe outside of the building, let's say in a crawl space or an attic, before implementing especially a demand control, you'll want to ensure those pipes are well insulated because they'll cool faster if they're uninsulated, potentially aggravating some of the issues we've discussed previously. And for complicated buildings or larger buildings, I always recommend looking at the plumbing plans if you can find them, if they exist. Interview the staff. Ask them if they've had any temperature complaints. And you might be able to ask residents this as well to get their opinion, because sometimes maintenance staff don't always have the same story that the residents have. You could ask the maintenance staff, hey, if this recirculation pump turns off, how long does it take to have a resident complain? And if they say, oh, usually, a few hours or 4 or 5 hours, then I think that would give you pretty good confidence that cycling your pump on and off will not create an immediate problem. But if they say, if I turn this pump off, I'll have a complaint in 30 minutes or an hour, that might be a good indication that there's something happening out in the field that needs to get fixed. You can ask them how often they change their cartridge mixing valves. And if their answer is, what's a cartridge mixing valve? Then you have probably a good indication that no maintenance has been done on those mixing valves and that repair is needed. Same thing goes for a question about crossover. If you ask them about whether they've had crossover in the building and they're not familiar with the idea, then that might give you an opportunity to sort of dig a little bit further. And conversely, if they know about crossover and they know about cartridge mixing valves, then that would give you some reassurance that maybe some preventative maintenance has been done. And to clarify, I guess this might be as good a time as any to discuss how to change cartridge mixing valves. Most manufacturers of single-handle mixing valves sell a cartridge replacement that goes into that mixing valve behind the handle, or they'll sell a seal kit that you can install on the mixing valve cartridge that will allow you to sort of rebuild that cartridge without having to open the wall. It may require turning the water off to the building, but it's typically a 1-hour task that most qualified maintenance staff can perform. There's caveats to this. Obviously, if you haven't maintained your system or you haven't pulled them before, there may be instances where the valve won't want to come out and you might have to open the wall if you want to work on it or skip that valve and go to a different valve. But generally speaking, changing the cartridge in most modern mixing valves is relatively easy. And I would say older mixing valves, very old mixing valves might have third-party cartridges that are available. So if you Google around on the internet the type of mixing valve that you have, you might be able to find a third-party cartridge replacement for your valve if it's a very old valve. So some other suggestions here. You find those plumbing plans if you can on these larger buildings. and study and understand the distribution system, and ask for help from colleagues if needed. I would definitely recommend bringing out a manufacturer's representative of whatever control you're planning to install to have them assist in understanding whether their control is compatible with the project, and to be part of the team to make sure that the project is a success when you do put that control in. And then this is sort of another suggestion, is to read Dan Holohan's books. Dan Holohan is sort of well known for writing books on domestic hot water, hydronic, and steam systems, and he has really good suggestions on how to understand how water moves through a system or through a building. He always likes to say, think like water. And a domestic hot water system is a lot like a hydronic system until somebody opens a tap. So understanding how hydronic heating systems work can help you understand how a domestic hot water recirculation system will work. And I always recommend, find the problem in the building before it finds you, and make sure you have a solution developed to fix that problem if it does show up. Getting back to the checkbook, make sure you have a budget for making necessary repairs. As we said beforehand, controls will make a situation worse if there are existing issues. And then identify what control strategy is most appropriate. If you look through the plumbing diagram, and making a demand control work in a large, complicated property or distribution system does not seem like it will be feasible, or will be complicated or expensive, it may be a simpler control strategy is the right strategy for that building. Again, we don't want to put a control in a building where we might cause an issue that leads to significant water waste. And then you'll definitely want owner and staff buy-in. If they're not bought into the project, then you might install a control, and if it doesn't work, a week or two later, it might get bypassed, and that basically is money down the toilet. They invested in something that isn't working. So you really want to make sure they're engaged in the project and bought in, and make those repairs visible to the owner that you've identified early on. They currently don't know that there's a problem sometimes. That crossover issue might be happening, but they don't know that it exists. You have to make these necessary repairs visible to the owner. And I usually try and couch it not as necessary for implementing this recirculation control strategy, because at that point they would say, well, it's been working the way it has, so why don't we just keep it as is? I think the argument is to indicate that they have, a lack of maintenance maybe that's been happening in their building, or this other problem that should really be fixed regardless of whether or not you are adjusting their pump. So I usually try and separate those repairs as more of an operations and maintenance repair than a bundled cost with the need to install recirculation control. And then the sort of last thought here is a suggestion for phasing improvements to make your troubleshooting more effective. If you install aerators, you install controls, and do lots of work on the system all at once, and then start getting any sort of complaint, you'll have a hard time deducing where that complaint is coming from, or what the issue is. So my suggestion when you're working on domestic hot water recirculation control is, first, make sure you solve all of your known problems first. Make sure all of the apartments quickly receive consistent hot water. Then install any low flow devices that you're considering, so shower heads and aerators. Wait a little bit, let's say a week or two, make sure there aren't any new problems. And then 3, once you've ensured that there aren't any issues, install recirculation controls, and then make sure there aren't any new problems. And I think another thing to mention here, something that happens typically that I run into, is you don't know the problems exist until you actually start talking to your residents. So I would even say with number one there is interview your residents and find out if there are any issues. Then you know if there are issues, you can solve them first. You don't want to get down to the end of your project and find out that, you know, Joe in that apartment has been having a problem for 5 years, and it always lets his shower run for 15 minutes before needing hot water. And I think we're at the point where we'll turn it over to questions. The new construction takeaways here that I have on these next 3 slides, you guys can look at offline, but they're sort of a recap of what we've already looked at. So I guess with that, do we have any questions?
We do have one question. However, it is specific to single-family homes, so I'm not sure if you'll be able to answer, but do you have a quick answer for what's the best solution for existing single-family homes and what potentially is the cost for that?
I think it really depends. So I would say the best solution, I would say, for my opinion, for a single-family home is the use of a demand-controlled type pump, because if the owner is motivated to sort of engage with their system and they don't expect it to work silently behind the scenes, then the kind where they push a button when they want hot water or trigger a motion sensor are typically the most effective recirculation control strategies. So only running the pump when needed. The timer or a variable speed pump or any of those other strategies would really run the pump much longer than it would need to.
Okay, great. Thanks, John. So far, no other questions, but just going to reiterate again, use the chat in the questions pane if you do have questions. The last section of John's presentation is going to be about new construction takeaways.
Okay, if there are any questions, I'll just bounce back up to new construction here. And so we have a couple minutes. So these are sort of the big picture recommendations I have for new construction projects for multifamily buildings. So the first one is make sure the plumbing engineer includes some form of balancing in their distribution system if it's a central hot water system. So that might be those circuit setters we talked about on each riser or a thermostatically operated circuit setter on the risers. Reverse return plumbing layout where the piping is sort of naturally balanced, and ensure that there's a third party that's going to test and balance that distribution system to make sure that each riser is getting the correct amount of flow. And even though it's code, require and visually verify that all pipes for the supply and the return lines are insulated to Title 24 requirements. It's unfortunate, but even though it's code, I see a lot of projects where this maybe doesn't get done either to the Title 24 thickness that's required, or the piping is not really very well insulated. So this is something to be aware of. And this is another thing that doesn't happen as often as you'd like, but really work with the plumbing engineer and the architect to lay out the plumbing system. I think you can use the look at the Greenpoint rated new construction manual for some good suggestions for efficient plumbing layouts. But generally, trying to specify a maximum distance from each fixture to a recirculation loop to ensure that you only have a limited amount of water waste in that loop or in that branch will help you reduce water waste. And that might require, an architect moving maybe a bathroom layout to a different side of a unit or doing something along those lines to get an efficient plumbing distribution.
Hey, John, before you move on,
yep.
When you talked about commercial grade fiberglass, that sounds like a good idea. We just don't know why you would use commercial grade fiberglass. Could you elaborate a little bit?
Oh, yeah, thanks for asking. So for a larger building, I would recommend a commercial grade pipe insulation over a residential grade foam type pipe insulation only because, or typically because, a commercial grade installation of pipe insulation will typically be done with more attention to detail than foam pipe insulation. So commercial pipe insulation will have an integral jacket, elbows, and other sort of fittings that will really typically create a much more continuous insulation around the pipe, whereas foam pipe insulation would require the same level of sort of cutting and fitting the pipe insulation, but I've generally found that the attention to detail might change depending on what's specified. You can achieve the same level of insulation value and detail with foam pipe insulation, but I would think on most larger new construction projects, they would typically specify a fiberglass type pipe insulation.
Okay, and then another question we had was, what time frame is considered good for getting hot water quickly?
That's a really good question. That EPA WaterSense standard has a volume in terms of cups of water that they consider to be good for how many cups you waste before the water gets warm. In terms of number of seconds to wait for hot water, I try and think about it in the perspective of being a resident. You know, how long would you be willing to wait for hot water before you walk away and go do something else before you come back for that hot water? And that's usually, I'd say, in like the shower type situation. And you know, anecdotally, I would say if you wait, if it's only a 15 to 30 second wait time to get hot water to start to come out of the tap, your resident is probably less likely to walk away and do something else. Whereas if they know that it takes a minute or 2 minutes to get hot water, they'll probably turn on the tap and do something else while they let the water heat up.
Awesome. Thank you, John.
So back to the new construction takeaways. Once you've sort of designed and put in an efficient distribution system, so well-insulated pipes, balanced piping system, and short plumbing runs or trunk runs to the plumbing risers, then you can sort of choose whatever control strategy you think is going to be the most effective at reducing your hot water gas usage. And I would recommend either a variable speed pumping system where you're using one of these newer pumps that will speed up and slow down based on a temperature that you set. And I would usually recommend that for maybe larger buildings. It might require multiple pumps for different branches. There's a variety of different things you could do to achieve a balanced system. Or use a demand-controlled pump, which, if you have balanced risers, well-insulated pipes, should work properly. And if you have a larger building, you might use multiple small demand-controlled pumps throughout the building if it's a larger building. And I would engage the manufacturer's representative of the control you're considering to help them work with you to make sure that pump is sized properly for doing a demand-controlled type of strategy. And a couple other thoughts here. If it turns out that your in-unit fixtures are remote from that central recirculation line, or are remote from maybe even their in-unit water heater, and this is pretty typical for new construction townhome type setups where the water heater might be located on an in-unit basis, maybe on the resident's porch, and their bathroom or kitchen might be relatively far away from that, you might want to include in-unit unitary demand-controlled pumps, the sort of residential version for each unit. And these also could be considered for retrofit situations where you have a townhome or a situation where each resident has their own water heater, but it's pretty far away from their fixture. And for new construction, I would encourage you to, if it's not already required by your local municipality, sub-meter tenants or direct meter tenants for their water consumption. That's a great feedback mechanism to tenants and will help immediately sort of keep water consumption in check. And sort of along those lines, if your building isn't, either you're already planning on putting in-unit domestic hot water systems on every unit, or you're putting in a central system, but for some reason there's no way to do solar thermal in the future, I would say move towards using efficient point-of-use domestic hot water or in-unit hot water appliances and meter tenants for their usage, as I noted above. So tenants are really, at that point, responsible for paying for their water consumption and their water heating costs, as long as we can use an efficient water heater. And that will help control water consumption. And as an owner, that will help control your costs as well. Okay, that's the end of the presentation. Does anybody have any questions?
Thank you, John. We are going to leave the webinar open to answer any questions that you guys may have. We know that we are over time a little bit, but we suggest that you guys stay around to gather a little bit more information from us. Sorry, here I'm trying to change it to myself. I just want to let you guys know that we have a few upcoming webinars coming up. Well, actually, first, let me talk about this. Sorry here, guys. This webinar series has been presented by the Energy Network. So for multifamily property owners and managers like some of you in our audience, the Energy Network Multifamily Program is a fantastic resource as it provides significant rebates and technical assistance to help you complete energy and water upgrades to your buildings. This program offers rebates for windows, lighting, HVAC, appliances, water fixtures, and plenty more. We're actually going to send out a list of applicable measures under this program that you can look over. Some benefits include lowering operating costs, increasing property value, and improving tenant retention. You can learn more by going to theenergynetwork.com or calling 949-264-2062. In addition, this webinar series has been co-sponsored by Greenpoint Rated, which John has mentioned throughout his presentation. Greenpoint Rated is the leading green home certification system in California with more than 31,000 homes certified, including multifamily properties. Greenpoint Rated is a simple, affordable, and flexible rating system used by countless builders and developers. It assures residents that a building is healthier, more comfortable, durable, and resource efficient. The Greenpoint Rated team is comprised of leading green building experts, and they helped put together this webinar series and set the agenda for which sustainability topics are most relevant to multifamily developers and managers like you. By visiting buildagreen.org/greenpointrated, you can find a multifamily checklist and see what kind of upgrades are factored into a Greenpoint Rated certification. And as John mentioned, there's also a new home checklist that you can also look at. As always, there are always educational events such as workshops, webinars, and trainings for you to learn more about energy upgrades and resource efficiency, I should say. We have a few webinars coming up. One right on the books is August 10th from 1 to 2 p.m., which is water conservation in multifamily buildings. With the drought heavy on our mind, this would be a great webinar topic for you to come and ask your questions. If you have, I'd like to thank John for giving such a great presentation today. I know that we have a few questions coming in, but what I am going to say is that we will answer any questions in a follow-up email. I want to be respectful of people's time, and we are running over just a little bit. So please keep sending in your questions as the webinar will be up, and expect to read the answers in the follow-up email. If you have any questions for the multifamily program in specific, you can contact David Myers, our Southern California Regional Director. His information is listed here, or Jonathan Austin, our Multifamily Sales and Outreach Program Manager. His information is also listed here. They'll be able to answer any questions that you may have. I'd like to, again, thank you guys for joining us, and thank you, John, for having such a great topic and really answering all of the questions that have come up. We hope to see you next time in the audience, and John, thank you again.
All right, thanks.
Have a good day, everyone, and keep the questions coming. We will answer all of them.